or even have a concept of what that means, how do I separate, maybe I separate control and data planes, which is a lot of what you see in the open, for example, OpenFlow switch. Very interesting stuff where you can use kind of an interaction of hybrid physical and virtual networking. So that really brings up this issue of programmable versus open and fixed versus proprietary networking stacks, which has a huge implication of what we do from a security perspective. It also brings up the issue in what we see both in the enterprise and certain cloud providers of this kind of classical data-only networking versus converging networking and data over 10 gig pipes on the same physical interface using things like data center Ethernet, fiber channel over Ethernet. So you can actually carry storage data, SAN traffic, and networking data on the same physical pipe. So if that essentially is now a single pipe, and most of our security products like firewalls have no knowledge or concept of what storage looks like in that regard, how do we actually deal with injecting compensating controls or even monitoring and providing visibility in those environments? And again, everything ends up being exposed via these interfaces for automated provisioning, orchestration, governance, APIs. These are things we're generally not used to being able to secure. Right? We can't just dump a firewall in front of this thing and expect us to add any value to this equation. So when you think about what this means to us, we have looked at what virtualization has done in the enterprise, and what it's really brought us is the fact that today, practically today, the virtual machine boundary is the new atomic unit of the data center, right? So it's really the logical perimeter that we talk about today, for now. And what that means is ultimately you're going to see the evolution of a new definition of the perimeter, but it's going to use different language, especially as infrastructure as a service bubbles up to platform as a service. So for example, Heroku doesn't talk about virtual machines. They provide Ruby on Rails capabilities hosted on top of Amazon. They talk about slugs and dynos. Anybody know what a slug or a dyno is? Most of you probably haven't heard of that. But these are new terms that denote workload and application and data content. And most of us have no idea what that means from the perspective of security, except for what we can gain from a programmatic perspective. So the cloud operating system platform networking in this particular instance has an awful lot to do when we think about where and how these VM boundaries exist in terms of our ability to enforce policy. So it determines on whether or not you get good enough or best of breed capability. It drives variability in how, what, if, or where you can even deploy compensating controls. And you have a choice now, right? Which is great, but you have a choice between much of the hamster security sine wave of pain, whether you deploy stuff at the physical, virtual, network or appliances, hypervisor or hypervisor API-enabled capabilities, whatever's exposed by the cloud provider, or in guest-based software. So, it's great to have choices, but in many cases, we don't have a lot of capability from the perspective of what's available to us from a control perspective that is available to us today that actually handles the scale, flexibility, and agility that the cloud platform itself derives. Right? So we're at the mercy of what a cloud provider gives us unless we want to continue to deal with this scale issue of deploying stuff in the guest. So when we think of storage, again, we talk about moving from local disk to SAN and NAS and object-based storage that's actually exposed via API. So you don't have logical file system units, you don't have disks, you don't have LUNs. What you have is an API you write to store data. That's kind of weird. Like, how do I secure that? How do I even know what it's being used for? By the way, it can be persistent or non-persistent, which means on reboot, it can go away. Or it can remain. Depends on the service level chosen, which is very interesting too, for forensics, but also for how I protect stuff that could essentially reboot and disappear momentarily. Volume, bucket, and file size limits are different than they are in traditional storage. We have converged storage and networking. IOM performance becomes an issue when we try to add security to it. It impacts tremendously how we think about application architecture. The notion that mobility of storage itself, like you got VMs moving around, but the file systems or the storage that actually holds the data that these things boot from, that interacts with, also has to move, sometimes across data centers. So BCP, disaster recovery resilience, is very important, and ultimately and clearly isolation and security for things like forensics in multi-tenant environments are huge. Like, how do you do a memory dump on a machine that has 384 gigs of physical memory that's segmented over, 15,000 clients? And make sense of what that means to you if you're doing a forensics investigation on a particular VM in one particular spot that could move. Very, very interesting challenges from the perspective of storage. So then we kind of go up the stack to metastructure. From infrastructure, we start talking about protocols. And Van Jacobson gave this really fantastic talk. It's about an hour and a half long. You can watch it on Google Videos at this URL down below. And he was talking about kind of the evolution of the internet, and I paired it well. I kind of paraphrased it for cloud, but basically he said, the cloud, or in this particular case, the evolution of networking, we was talking about it, is really like where ARPANET was yesterday. And this quote he used was, at the outset, the new network looked like an inefficient way to use the old network. And that's kind of where we are with cloud today, right? We're looking at what cloud offers, and we say, well, that doesn't make sense based on what we know of networking and security today. He said, what's interesting, when it was created, TCP/IP was not made for ubiquitous any-to-any communication. At that point, there were a couple of these giant machines sitting in these glass rooms with a couple of users with a little bit amount of data and information that would talk to each other. Right? So what was interesting was when you look at that model and where TCP has evolved, the things ultimately that people were doing with, for example, even the telco environments, making phone calls, was actually a side effect of what was done inside the network. So when we think about cloud too, what cloud does inside, the mechanical pieces of what it is able to offer, the use cases are actually the side effect of that based on how you actually design the stacks and what they're optimized for. So communications today, as Van Jacobson said, are really disseminatory. You basically say Marco, and a whole bunch of people can say Polo. You make one request, it's very asymmetric. You make one tiny HTTP request, and you get petabytes of information back if you want it, right? So it's really about disseminatory versus conversational. So the notion of locating where stuff is, naming location, and trust models are a huge issue. So when you get down to the end of it, today's networking protocol problems that we have at the metastructure layer, like DNS, like BGP, like all these things we see, coming back in style that are being attacked today, and the fixes we're putting in place, like DNSSEC, as Kaminsky's been talking about, it's really not an architectural failing. It's really actually what Van Jacobson called a success disaster, right? The side effects of what TCP/IP brought and the innovation that people use to leverage it really is a success disaster. And we're dealing with what that means because the infrastructure, again, if it was never built to do that, doesn't give us very quickly the ability to handle or secure it. So what's interesting is that we kind of bubble up the stack and we think about infostructure. This is the very interesting and fascinating part here, where architecturally, your classical n-tier design and segmentation and asset grouping methodology that you used to use may no longer apply based on how the networking and platform of the cloud provider functions. It may not make it any sense whatsoever, right? There may be kind of a shadowing notion of how I divide assets into logical groups, but they don't look anything like DMZs today, especially if we think of that VM boundary that I talked about. Applications are likely not composable this way anymore because they really talk about being very distributed, as that shifts in architecture talked about. And they're becoming much, much more topologically and infrastructure insensitive than ever before, right? They want big, giant, flat layer 2 networks. In many cases, you have to completely rewrite your applications to make use of the platform in public cloud. And the security models have to change then. And so ultimately, when you look at this and you think of abstracted dumb networks, in many cases, dumb networks equals dumber security from the perspective of visibility, or at least it gives us less options in many cases until stuff catches up. So workload sensitivity, or the network being aware, the network in the sum of all its parts, being aware of what is running over it is really, really important. So people still write crappy code, so no matter how good or abstracted ultimately the infrastructure is, that's still a problem. And if you look at the fact that people continue to now adopt this notion of DevOps or agile code deployment, constant deployment methodologies, people are pushing code constantly. So how are you going to secure something with no known state that ultimately is not persistent, that doesn't survive a reboot that could change every 10 minutes? Right? How do our security models adjust? And so when we think of things, this is out of an AWS design presentation, which talked about the fact that we have a lot of decoupling here. Like if the top level were controllers, or in this case programmatical functions, they used to be where one would call another, one would call another. Well, now we have this separated. Now we have essentially controllers talking to queues and message buses, which if you've done anything in enterprise architecture and software SOA architecture, you may be familiar with, but most of us don't think of this way. We're used to essentially deploying kind of this notion of firewalls in between these classical tiers and everything's going to be okay. Well, ultimately, now not only do I have to control the VMs, the processes, the controllers, I have to deal with securing the queue and the messaging that's used in between them, which is not a new concept, but the point here in arguing is that fundamentally the solutions aren't flawed, but the problem has radically changed, right? I made that point to Vint Cerf, and he literally kicked me in the ass. So the notion here, when we think about security models from an infrastructure as a service perspective, and we look at where the line is drawn in terms of responsibility of who does what, the lower down the stack you go, the more responsible you still are. So if you look at infrastructure as a service, right, everything above that orange line is you. You still have to do all of that regardless of the fact that you outsourced or you are giving somebody else control over the infrastructure. Platform as a service essentially moves the line up a little bit more. Software as a service, even more so. So when we think about this stack and we think about this portion to the left, since we're talking about infrastructure as a service, all of that security capability and functionality is all you. And when you think about the fact that the VMs and especially the operating system and applications are radically changing, that kind of presents a challenge. So when we think about this, there's not a whole lot you can do there at the infrastructure layer. So if we focus here, what this really means is if I have to secure the VMs or my containers, the OS and applications and my data, it really falls upon these three fundamental premises of what we're here to talk about. Building survivable systems that sustain attack regardless of what the provider themselves do, building secure applications, and securing your data. Oh, what a shocker. Right? The reality is these are things that we still do regardless of the deployment methodology. So when we think about these three things, and we move up the stack to talk about what survivable systems are, it really means in many cases that if you continue to build based on what you think are relevant design patterns in the enterprise, you are certainly going to be, as I say, kind of, if your security sucks now, you'll be pleasantly surprised by the lack of change when you move to cloud. Right? And that's kind of the message. When you look at that same presentation I referenced before, architecting for the cloud, here's the recommendations from Amazon, right? Design for failure. Basically what this means is cloud isn't unreliable, but the mechanisms that make up the pieces of cloud independently may be unreliable, and any piece of them can, do, and will fail at any time. So design for failure. I don't know about you, I don't get paid to design for failure. I get paid to protect based on maximum uptime, and that's kind of a disconnect. We talked about decoupling all pieces of enterprise architecture. Think about elasticity. Think about the security models. Break constraints, both programmatically, policy, from the perspective of how we actually think about design. Think in parallel. Think about different storage options. So this is advice in terms of public infrastructure to cloud that's really targeted towards system administrators and developers. The security model elements we'll get to in a minute, but when we talk about design for failure, it means that your backup and restore strategy has to radically change. That your applications and your infrastructure has to be impervious to reboot or relaunch. That you have to think about the fact that you have to move in-memory state of applications and data to data stores. Again, storage. For persistence, you should think about, as we always should, using multiple availability zones and regions for high availability, using software-driven load balancers or hardware, depending upon the cloud provider, using relational database services that exist to essentially enable the use of elastic infrastructure in a data or database environment, and then using this notion of elastic IP, where the IP address is no longer the static constraint of where something lives or operates. So in this particular case, you may find that you are leveraging provider-specific attributes to get stuff done, even if you re-architect all the stuff, which may be fantastic if you plan to single source your provider to a single provider, no matter how resilient they are. If you want federation, if you want interoperability and portability from a security perspective, what may work in one provider may not work in another. And this is an issue with where the arguments about the need for standards come up. Or at least a standardized way of explaining or expressing what it is we need. So I found this set of advice very interesting. I further found that last year at Source, Alex Stamos from ISEC gave a great presentation about securely moving your enterprise to the cloud. And his presentation was really good. What was interesting was he basically said what was kind of reiterating what was there in Amazon. I said, look, your current thoughts about cloud computing and security in cloud computing is missing the point. That you cannot securely move into the cloud without rewriting your software. And he's talking about public cloud. That secure cloud applications really talk about collapsing the perimeter, kind of like that VM model I talked about. And that ultimately, by the time you go through this whole process, if you do it successfully, you should be quote-unquote more secure. Well, I looked at these points, and he went through a whole series of illustrations, and what that really meant is, for him, summarized in these points, that you should, from a networking, from a software architecture perspective, go completely flat. That you should collapse the perimeter, use external or even internally offered glue services that allow you to dispatch and separate infrastructure from applications and use message queuing, and use a shitload of crypto. Now, this is interesting and good, except, and it sounds easy enough, but there's a big difference between greenfield applications and the legacy apps and crap and bloatware that we have to deal with in an enterprise, right? I don't have the source code. I can't rewrite Exchange. I don't have that option. right? I can't rewrite a number of legacy applications. I'm able to move them, they may not be efficient, but then if I can't leverage the elasticity and the benefits of cloud, ultimately I end up hitting roadblocks that are unintentional and not the provider's fault. It's the application architecture issues that start to preclude me from being able to